And welcome back. Now we'll talk a little bit about floating point numbers and how floating point numbers work, or real numbers, things with a decimal component to them. You've got basically three kinds of floating point numbers, not including the typical signed and unsigned stuff. You've got a float, which is a floating point number that's basically 4 bytes. It's between 3.4 to the 38th power plus or minus. You've got a double, which is twice that size, so it's 8 bytes. So that's between 1.7 to the 308th power plus or minus. And then you've got something called a long double, something I very rarely use, which is the same size as a double, but on some compilers they can actually use up to 10 bytes for this, which gives you even more ranges. So that gives you from 3.4 to the 4,932 power plus or minus, which gives you lots of space. Most code, though, we use typically is going to be a double or a float. And most of what I demonstrate is probably in the lines of a double. Now, the reason we have floating point numbers, and typically things when you're mapping stuff from real world into code, doubles are things that are going to be of a fractional value, things like money, any kind of division where you need precision resulting in it. So if you had, for example, the price of an item would be something that you definitely need to have as a double, and you're typically going to store it as a 0 to start it off and initialize it. And let's say you've got a tax, so you have a tax rate, which here in my happy little state is 7%. And there we go. Now the smart, sharp-eyed ones of you will remember that anytime we type something in that's not going to change, and our local tax is probably not going to change in this program's lifetime, we want to make what out of it? Yes, we want to make it into a constant. And then, of course, we'll change the title of it, or the name, to all caps to follow the style of how we use constant variable naming. So if we wanted to print out the price, that would print out the price. Notice again, if you remember from last time, this is a string literal, so it's got that null character hiding in the back end of it. It's not a real string. If we wanted to print out the tax rate, and then if we want to do a little bit of math with it, we can actually print out what your tax would be on a given purchase of a certain thing. If I could type. And if we want to do the total, well, you got to do the total. How much you're going to really pay for something, assuming you pay tax. And the sharp-eyed ones of you will know that we didn't actually give ourselves any kind of price. So let's go up here and assign something. So the price is going to be, in the end of this, so $42. So there we have it. Our price is $42. The tax rate is 7 cents. And we'll run the code and see what happens. Forgot a space. And here we go. Price is 42, tax rate 7%. Your tax is $2.94, about right. Total is going to be $44.94. So if you add the two up, that looks good. And this is the basics of doubles and how we put them into our system. You can, of course, put other types of numbers, larger or smaller, in here to make it work for you. But in the scheme of what we do in this class, we're just looking at the basics of it and how to run it. And there you go. That is the end of a quick introduction to how to load floating point numbers, doubles. Again, how to make a constant of a floating point number, and how to do a little bit of math in your output statement. Notice This is typically done when you do it straight into output, when you don't need to save it. You don't need to do anything else with it. If you wanted to make this a little more efficient, you'll see the price times tax is done twice. And while the compiler can optimize things and do stuff in the background for us, we might actually want to have something that's like this. Or maybe not exactly like that. And then come up here and do our calculations. Shortens things up just a little bit for us. We don't have quite as much duplication of code. And anytime you see that in your code, if you're seeing things that are duplicated, maybe saving it and the space that it takes to save it is worthwhile, maybe not. You'll have to try it and find out. Oh, my tax is 0. Why? Oh, that's why. If I put my code here, it doesn't do it. I need a price. And there we go. And for those of you who care, part of the reason I do this live without actually having to do an edit and make it all clean and pretty and never make a mistake is everybody makes mistakes when you're coding. Part of it is figuring out what you did wrong and where. And this original line of code being done up before you had a price is a very common error. Doing the math before you have the values, it's a very common error all the time. So again, declare your variables, load your variables, do your processing, throw the math together, and then output the results. Input, process, output is kind of the nomer that we use for coding. And with that, we will move on to the next section.